want to approximate the area of the first quadrant region bounded by the curves y equals 7x over x squared plus 1 to the 3 halves, and y equals x squared over 3. So first quadrant, so we know we're only talking about like positive x's and y's. But here's the problem. We need to find out where these things meet. And if we set them equal to each other, is this going to be an equation we can solve? Not really. We can cross multiply. But I can't distribute this because of the 3 halves power. And so I'm kind of stuck at this point. So this one, we are going to use our graphing calculator to help us find that intersection. So you go to your calculator, go to your y equals, and our first one is 7x over x squared plus 1 to the 3 halves. And the second one, x squared over 3. Okay, so then if we look at our graph, and one of them is doing something like this, and one of them is just a parabola. Okay, since we're talking about the first quadrant region, we know we need to find these intersection points right here. This one you might be able to tell. What does it look like it is? 0. You could confirm that by plugging 0 in, or we can look in our calculator. If you go to second, trace, number 5, intersect. So second, trace, intersect. Then it says first curve, and it tells us up at the top the y1 equation. So just hit enter. Second curve, it switches to the y2. Hit enter. Guess, you just have to get close to that point and hit enter one more time, and it tells me the first intersection is at x equals 0, y equals 0. So 0 is the first one. Now we need to find the second point, so we just repeat that. So second, trace, intersect. First curve enter, second curve enter, guess, so we get closer to that point, and that one is not pretty. 1.963. We could definitely keep more decimals if we wanted. Did everybody get that? No? What?
I don't even know. I'm just like, oh.
Okay, so we want to integrate from 0 to 1.963. These are x values, so this is a dx. If we're doing x, it's top minus bottom. What's the top one?
The blue.
The weird one. The 7x over blah, blah, blah. Okay.
So when's the one where we go right to
If you're doing in terms of y. Minus x squared over 3. Alright, is this going to be an easy integral? X squared over 3 isn't bad, but the first one is, so I'm going to break those up. So this is 7x times x squared plus 1 to the negative 3 halves dx. And we'll do minus integral from to 1.963. And I'm going to write that as 1/3 x. This one's no big deal. But what am I going to have to do to integrate this? Substitution. U, what's the inside? Du would be, and I don't need the 2, so 1/2 du is equal to x dx. Okay, let's go ahead and change our limits. So if I put in my 0, 0 squared plus 1 is 1. If I put in my 1.963, so 1.963 squared plus 1, so then we kept the 7. The x and the dx get replaced with our 1/2 du. So could I write that as 7/2? Is that okay? We have a du. And then the x squared plus 1 became my u. So u to the negative 3/2. Add 1 to the power. So that's negative 1/2. So reciprocal in front will be a negative 2. So that makes that a negative 7. I'm sorry, I know I did not leave you guys enough space on there. Just trying not to use another sheet of paper. That was rude. Sorry. Okay, so if we plug in, we have 4.853 to the negative 1/2. Minus 1 to the negative 1/2. And I'm just going to put all that in my calculator because it is not pretty. It's 3.8221. But am I totally done? I have to do the other one. No. It should be nicer because I don't have to do substitution to integrate that. That's why I broke them apart. Antiderivative of x squared is x cubed. So 1/3 times the reciprocal of 3 would be a 1/9 from 0 to 1.963. Get 0.8405. So final answer, what am I doing with those two numbers? Subtract them. You get 2.9805. Obviously lots of rounding error here, so this is probably not perfect because we rounded several different places, beginning with the intersection and then throughout our problem, but it gives us a ballpark. So this one, and it was kind of a clue in the directions because it said approximate, so it was one that just didn't work out nicely, it didn't have a beautiful intersection point. So we had to use the calculator to approximate it. Alright, any questions there? And you guys have some homework to be